the very first thing we did was that. What was that? What's that? I really hope you write this down then. When we first started talking about right triangle stuff, we had to first talk about the Pythagorean theorem. Pythagorean theorem works for only right triangles. Okay? And when you worked with right triangles, this is how we solve a missing side in a right triangle. Now, when we did this, we also worked with the Pythagorean theorem going backwards. So if we look at the Pythagorean theorem saying a squared plus b squared equals c squared, if I say it backwards, we said c squared equals blah, 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 blah. But remember how we did this 3 different ways? We had c squared equal, we had c squared was greater, and we had c squared was less than. Now remember, in a triangle, the value of c will always play the role of the longest length. Excuse me. I think that the weirdest problem we came across with some of these is when you had a radical with a number in front of it, and you had to square things and stuff like that, so you have to be careful with those. But we had 3 different ways that you work, 3 different types of triangles that could have been created depending upon the side lengths. We had, if c squared equaled a squared plus b squared, we knew it had to be a right triangle, because that's just the Pythagorean theorem. And then we had 2 other types of triangles. We're talking about side lengths. It was either acute or obtuse. And the reason that we wrote the c squared first is because if c squared is bigger, it is obtuse. If c squared is bigger, it's obtuse. And if it's smaller, it is, by process of elimination, it goes that way. And those are really simple. That was kind of one of the first few things that we did. Let's see. After that, we switched into we jumped right into, we did our special right triangles. Those have been a while. Ooh. I will wait a second and go have a sip of coffee while you finish writing that out then. Excuse me. I'm not kidding. Alright, after we did the trig stuff with the right triangles, then we jumped into this good old fun stuff. Yes, ma'am.
That's tomorrow. Yeah, tomorrow.
Yeah, this is all this stuff. That's why I'm going over it. I got a whole bunch of stuff to talk about today.
And tomorrow?
Yeah, there's a lot in this stuff, guys. I can give you a test tomorrow if you want.
No.
But you're whining. Now, remember, when you had your special right triangles, you had specific ratios that always held true. And instead of saying 1 root 3 and 2, we wrote it as x root 3 and 2x. And the reason that we use these arrows is because the angle always looks at a side opposite. Now, depending upon the type of problem, depending upon the type of triangle, you had different ratios to work with. there's only two special right triangles that you had to worry about. The 45, 45, 90, and the 30, 60, 90. Those trig ratios will hold true over the course of the next couple of years of math that you do. Because algebra 2, when you get to trig, and I know I've said this, it's based off of these two. Same thing with pre-calc. Okay? Now, as you get into these, it was always dependent upon what you were looking at. Somebody turn off their music, please. Thank you. Extraordinarily loud. So, depending upon what triangle you were working with, depending upon what information you knew, you had to set up something. For example, let's say we have a 30, 60, 90 triangle, and you knew across from here was 12. Every single time that we did a problem like this, we always set up what I call that algebra jig. And we knew that across from the 90, it was looking at a value of how much in this triangle? 12. So I know that across from the 90, it's looking at a segment that is 2 times something. That 2 times something happens to equal 12. So then I would solve for x. 2 times what is 12? That means I just solve for the value of x, this common ratio, there's an x equaling 6. That entails that, or that means that everywhere I see an x in this problem, what do I replace it with? 6. Then I go on my merry way. It doesn't change. Okay? The weird one was always for the 30, 60, 90, if you had extra roots or things like that thrown in there. For example, let me just go back to the same setup here real quick. And let's say across from our 30. Let's say across from our 30 was the square root of 3. And we'll make it weird. We'll say it's the square root of 3. Now, going back and looking at that algebra jig, if you will, that means that the 30-degree angle always is looking at some value of x. Well, in this case, that value of x happens to equal what? Square root of 3. Which means everywhere I see an x, what do I replace it with? Square root of 3. So then I have to just multiply out root 3 times root 3. What's the square root of junk times the square root of junk? Junk. So what's the square root of 3 times the square root of 3? 3. And those are my answers. Calculator will do all that for you. Okay? Once you isolate what your value of x is, you're just replacing it everywhere else along the string. Okay? If it's a 45, 45, 90, do things change? Well, no, you just have different ratios. Say we have 45, 45, 90, and we know across from the 90 degree was 10. What? No? Yes. Because remember, that 90 is looking at a value of something times the square root of 2. So the 90 is looking at something times the square root of 2 that just so happens to equal 10. How do you undo multiply? Divide. So when you divide out by the square root of 2, your calculator will do that, but do you remember the shortcut? What's half of 10? Slap a root 2 next to it. Whenever you're dividing by the square root of 2, cut the numerator in half and slap a root 2 next to it, and there's your answer. So 10 divided by the square root of 2 is 5 root 2. It works every time. But remember, your calculator will do that, which means come Friday, what do you have to have with you? Okay, so we did that. After that, we switched into SOHCAHTOA. And quite honestly, you guys are fine with that. You just haven't seen it for a while because we've done a lot of elevation and we've done a lot of angles of depression, and then we did the law of sines. But SOHCAHTOA, that was quick. As you guys get going into SOHCAHTOA, it's remembering what does it mean. So sine is what over what? Cosine. And then lastly, and if you guys recall when we did those quick quizzes on these things, you guys are flying through those. Remember how we did a lot of, I always wanted you guys to write out the setups of what you would do before you press buttons, and you guys basically aced it. So it's just a matter of remembering how the setups work. Every time that you do these, whenever we're working with SOHCAHTOA stuff, we always wanted to do the same thing over and over again. Didn't matter what it was. If we had a triangle, I knew this was 13. I knew that 13 degrees, this was 7, and this was 41. Well, I'm sorry, let's just do one. I'm just making up numbers. If I wanted to figure out what that side was, or all the remaining sides, if I wanted to find the remaining sides and the remaining angles, just like we did all before. In this case, how many sides do I have to find? 2. How many angles do I have to find? What's the easiest thing to find first? The angle. Because we know that all 3 angles have to add up to equal 180. But I also know that the 2 angles that aren't right angles have to add up to equal 90. So 90 subtract 13 gives me 77. Okay. So I know that one's easy. I get 77. Now, when we did this, I asked that you guys write out what you had to find. So you had to find angle C. We have to figure out what AB is. And we have to figure out what BC is. Remember all that? And it's just a matter of identifying parts. So if you start with what you were given, remember how we always circle the angle? Where do I draw to? Your opposite, very good. There's my opposite. 41 is my hypotenuse. And then by process of elimination, what trig function do I use to figure out what BC is, my opposite? You're right, I'm going to use SOHCAHTOA. So yes. Which part of the SOHCAHTOA do I have to use? Sine. I have to use sine because it's the opposite. Okay, opposite hypotenuse. Gotcha. So I have to do the sine, I forgot what my name was, of 13. BC. And my hypotenuse was 41. Whenever your unknown is in the numerator, all you have to worry about doing is multiplying by your denominator. Just bring it up. We get 41 times the sine of 13. That'll give me BC. What trig function do I then use to find my adjacent, knowing the hypotenuse? Sine. I have to know this. We get 41. And I'm writing all of it out before I get to the point of pressing some buttons. Okay. When I go to start pressing buttons, that's the easy stuff. So if I start typing this out, 41 sine 13, I I get 9.22. And if I do 41 cosine of 13, I get 39.95. We'll get it back. Remember, it's just a matter of writing out what you're about to do before you do it. That's the trick. Also, having a calculator is kind of a smart idea. We always round to 2 decimal places. Always go with 2 decimals. Okay. After we did that stuff, and we did a ton of that, and that's kind of like. Yes, ma'am.
Okay, so this is where I always mess up on this. Okay, so when it has two, I always do the one that we have the two numbers. And then I end up getting it wrong. Okay, so like say we had the height and the op, then I would use the
Oh, you're trying to find the angle?
no for the other side. I don't know. Like I always mess up with this.
Just remember that you always go with what you're given, so you don't use that. I have 13, it looks at my opposite. Opposite hypotenuse is sine. So the sine of this is whatever that is over 41. Figure that out. Start over. I need to find an adjacent, go to the hypotenuse, different trig function. Cosine of that is whatever this is over 41. So just different buttons to press. Okay? That's why you always change. You remember, trig's all about changing perspective. You're switching parts that look for it. It's just a matter of re-going with what you're looking at. Sir. The only thing that I would say, what happens if your 922 is wrong? Now, let's say you accidentally typed in 15. You did sine of 15 to get, like 41 sine 15, not sine of 13. You'd get a different answer, which means you'd get the wrong answer then for the next one. By reusing givens and going through it that way, you could theoretically get this part wrong, but since you're not using this to solve for that, you could get this right. All right, so that's why I always say reuse your givens. Always try to go back to your givens so that you don't make that mistake. Yes, ma'am. The best person in the whole wide world. Oh, excuse me. Like what? Well, why would you do all that and not press enter? Those were the idea of when I was setting those up was quite honestly showing you guys how easy this really is. Building your confidence. I know I'm not always, fire and brimstone and just yelling and screaming at you because I hate you. Because I really don't that much. But I try to make sure that you get really good at looking at the big picture. Because if you can set up the problem, that's 9/10 of the thing. Pressing buttons is easy. Understanding how you get to that point is the tough part. That's why we spend so much time on it, because now this is the easy part because you know how to set all that up. Okay? Don't worry. She's worried. Now, what I have here is I have a bunch of extra problems as well. And I want to get these in your hands right away because I want to walk through a couple of elevation problems as far as a couple of sign things too. I kind of overdid with the problems. Just because you're in the corner, we've done that one side. So, real quick, what I want to do here Flip over to the third page. Before I get too far, on the bottom portion, those 6 problems are all about law of sines. Cross off on the bottom part here the 2 triangles of 7 and 8 because it's just duplicate problems. What I did there is I quickly put together some problems that both had where you had to find an angle first or you had to find a side first. So if you can do it twice, you don't have to do it thrice. Take a look at number 8 on the top here about the angle of elevation. Find the measure of the angle of elevation of the sun when a vertical post that's 15 feet tall casts a shadow that's 20 feet long. So that means you have to understand what that looks like. What is a vertical post? A vertical, correct. How tall is that? Where does its shadow lie? The ground. How long is the shadow? Find the angle of elevation that it makes from the ground to the sun, which means if the shadow is on this side of it, where's the sun? He's wearing sunglasses today. What trig function will allow you to figure out the angle of elevation in this problem? Very good, very good, very good. So in this case here, you're using your angle of elevation to draw yourself a picture. And remember, whenever you're trying to find an angle, that is the only time you have to press the inverse button. Every other time that you have an angle, you're just pressing buttons. So let's see here. That means we have the inverse tangent. Uh, 3687? Yeah. You guys get 3687 when you round that out 2 decimals? Okay. Take a minute and try 9. Take a second and try 9 with the elevation one, okay? A plane takes off, and it goes whee. No, it's whee as it's climbing. Yes. After takeoff, the plane flies in a straight line for a distance of 4,000 feet to gain an altitude of 800 feet. Altitude, remember, is your vertical distance. If it's taking off, that means it's rising over some, it's rising over a specific horizontal distance to reach a specific vertical distance. It rises on this diagonal distance for 4,000 feet to get to the vertical height of 800 feet. Well, normal airplanes don't just go.
Bro, you just showed us something.
That is a special airplane. It's not one that you're gonna fly. That.
Oh.
Not all airplanes do that. Are you gonna get that?
I guess.
Sorry. What trig function do I use now to figure out which one? Sine. This one will be sine. Okay.
Like they understand if we say sin.
No, it's sine.
But what if we say sin? Would they understand?
Who?
Who are we telling?
No, they're gonna throw stuff at you. They're gonna throw their books at you.
I am a scholar.
Obviously, you're using the word ain't.
Is it a word or not? No? Oh, it's, I was using ain't in a word.
All right, so let's see here.
It's not a word.
Inverse sine of 800 divided by 4,000.
What would it even, if it were?
1154? 1154? Nice Murphy joke. What? Okay.
Yeah. You need to tell her that she needs to round try to get round because she does not do it. And I keep telling her and we keep telling her.
Okay.
Because he says you do it different in her class. And I said no.
No.
He does it the same.
Also, so what I wanted you guys to try and go through here is I kind of made a quick little cheat sheet about all the different parts on this review packet. And what I did was, there are certain parts of this sheet, of all these pages, you don't have to worry about. What I would suggest right now, if you have not, or obviously you can write all this out, take your phone, take a picture of that, because that explains to you every page on here. So this first page is talking about the first 4 problems are just Pythagorean theorem. The bottom of that first page are your special right triangles. Okay? It just kind of tells you what you want to say. It kind of tells you about what you were looking at to be able to do to solve. The top half of the second page is all your SOHCAHTOA. The bottom part, which starts at 19, is when you rotate through 2 triangles and specials. And we'll do some of those tomorrow. The third page, the top 4 are just elevation, depression. The bottom of that page is all law of sines. Yeah. I'm going to be going over a ton of this. I haven't quite decided yet if I'm going to collect out. I'm hoping, and I'll tell you, I want you guys to get the first and third pages done for tomorrow, because those are the quick ones to be able to go through. The other ones will take a little bit longer. Yeah. And then the very back page, really the only problems I'm looking at doing, because they're hard to find extra problems, are 1 through 7. And the 4 through 7 on there are the ones where you have to tell what kind of a triangle it is via the side lengths. Is it a right triangle, obtuse triangle, scaly, or not scaly, excuse me, acute triangle? That's what we're talking about for here. We're going to go through a bunch of this again tomorrow and continue on. Good times. Thank you.